Imagine for a moment that every single person on Earth, all 8 billion of us, gathered together and decided to jump at exactly the same time. The countdown begins. 3, 2, 1. Jump. For that tiny moment, not a single human is touching the ground. The entire species is suspended in midair, united in one impossible act. But when we land, what really happens? Would the Earth shake beneath our feet? Would it move through space, even slightly? Could our combined force actually make the planet budge? The truth, backed by physics, is both fascinating and humbling. The average person weighs about 60 kilograms, which means that if you multiply that by 8 billion people, humanity's total mass comes to around 500 billion kilograms. That might sound huge, but Earth itself weighs about 5.97 septillion kilograms. That's a 5 followed by 24 zeros. Compared to that, we're basically nothing. All humans together make up less than 1/1000% of Earth's total mass. So, when we jump, the planet barely notices. Even though every action has an equal and opposite reaction, the Earth's reaction to our jump is unimaginably small, about 100 billionth of a millimeter, smaller than the width of an atom. Technically, yes, the Earth would move, but practically, not at all. When everyone lands, it gets even more interesting. Billions of feet hitting the ground at once might sound like a global earthquake, but because people are spread across continents, the energy spreads out instantly. There's no single point of impact, just billions of tiny ones happening far apart. That means the effect cancels itself out. Seismographs, the instruments used to detect earthquakes, wouldn't even register it. The tiny motion the Earth gained when we jumped would disappear the instant we hit the ground again. In the end, the planet stays exactly where it started. But what if we took everyone and put them in one place? Let's say the whole population of Earth somehow stood shoulder to shoulder in a giant open field the size of Los Angeles. Then we all jump at once. That would definitely make the ground shake locally. Scientists estimate the energy would be roughly equal to a small bomb, enough to make a loud thud, crack the ground, maybe shatter a few windows. But even then, on a planetary scale, it's nothing. The Earth wouldn't shift, its orbit wouldn't change, and its spin would continue exactly the same. From space, satellites wouldn't see a thing. It would be like trying to move a mountain by throwing a pebble at it. To actually move the Earth, we'd need an unimaginable amount of force, the kind produced by massive asteroids or planetary collisions billions of years ago. Even the strongest hurricanes, earthquakes, or volcanic eruptions barely make a dent in Earth's motion. Compared to those, 8 billion humans jumping together are like ants trying to shake a skyscraper. It simply doesn't register. Still, there's some